So let's do this problem. In this case, we have a problem. Sulfur trioxide reacts with water to form sulfuric acid. If 20.00 grams of sulfur trioxide reacts with 10.00 grams of water, how much sulfuric acid is formed? That's the question. So first of all, let's write the equation out. So sulfur trioxide plus water to give sulfuric acid, H2SO4. And let's see if the equation is balanced. And sulfur, and we have 4 oxygens and 2 hydrogens. So yes, it's balanced. So the question is then, if 20.00 grams of sulfur trioxide reacts with 10.00 grams of water, then how many grams of sulfuric acid are formed? So this is a limiting reagent problem, because you have to figure out which of these two reagents are going to stop the reaction. So let's start with sulfur trioxide, and our strategy is the same. Okay, so we'll convert the 20.00 grams of sulfur trioxide to moles of sulfur trioxide. Once we get the moles of sulfur trioxide, then we'll do the mole ratio, and 1 mole sulfur trioxide has 1 mole of sulfuric acid, and then convert the moles of sulfuric acid to grams of sulfuric acid. Let's go ahead and put in the numbers. And in 1 mole of sulfur trioxide, we have 80.06, which is 1 sulfur plus 3 oxygens. That gives you 80.06. And then in 1 mole of sulfuric acid, we have 98.08 grams of sulfuric acid. The 1-to-1 mole ratio is coming from the equation. So once you do the calculation, the answer is 24.50 grams, okay, of sulfuric acid. Let's do the same thing for water now. And so we have 10.00 grams of water. Convert that into moles of water, grams of water, and then the mole ratio. So moles of water, moles of H2SO4, and then convert the moles of sulfuric acid to grams of sulfuric acid. Okay, and so in 1 mole of water there are 18.02 grams, and then 1 mole of water will give 1 mole of sulfuric acid from the balanced equation. We calculated this mass already, and it is 98.08 grams of sulfuric acid. Once you do this calculation, your answer should be 54.42 grams. So you pick the lower number then, okay, and in this case the lower number is 24.50 grams. So which means that SO3 is the limiting reagent, and 24.50 grams of sulfuric acid are made. Okay, so that's your final answer then. Let's do another problem. And in this case, this is a reaction of oxygen and hydrogen. Okay, so during the launch of a shuttle, 4,400 kilograms of hydrogen reacts with 31,000 kilograms of oxygen. What is the limiting reagent, and how much water is produced? So it's giving you the product also, okay, in there, so it will help you write the equation. So our answer is then we have hydrogen plus oxygen to give water. That is our equation coming from here. There is no other product given, so this must be it, and all the atoms are accounted for. The only thing is you have to balance the equation. So 2 oxygens on the left side, 2 oxygens on the right hand side. Okay, and so we have 4,400 kilograms of hydrogen and 31,000 kilograms of oxygen. In this case, we have an added conversion to do. Okay, so we have to find grams. Okay, for the kilograms, I'm going to do this problem a little bit differently. I'm not going to take it all the way to grams of the product. So I'm going to do this slightly different, and you can do it either way you want. You want to do the first one or the second one, it's up to you. Okay, so let's go ahead and start with hydrogen then. So we have 4,400 kilograms of hydrogen. Convert that into grams. So grams of hydrogen, kilograms of hydrogen as usual. I'm going to wait to fill the numbers out. Write my units first, converting it into moles of hydrogen, and then from moles of hydrogen I will find out my moles of water, okay, that are produced, because that's my goal. And I'm going to stop here. I'm not going to find out the grams of water yet. I'm going to calculate up to moles of water and then do a comparison for moles. Okay, then let me fill in the numbers. In 1 kilogram I have 1,000 grams. In 1 mole of hydrogen, I have 2.016 grams of hydrogen, and then 1 mole of hydrogen gives me 2 moles of water. Okay, so that is our mole ratio. Once you do this calculation, your answer should come out to be 2.18 times 10 to the power of 6 moles. Okay, and this is the moles of water. We'll do the same thing for oxygen. And we'll start with 31,000 kilograms of oxygen. As usual, I'm going to do my units first. So kilogram oxygen, gram of oxygen times grams of oxygen to moles of oxygen, and then my mole ratio, moles of oxygen to moles of water, and I'm going to stop here again with the moles of water. So in 1 kilogram, yet again I have 1,000 grams, nothing has changed there. And in 1 mole of oxygen, I have 32.00 grams of oxygen coming from the periodic table. Again from the balanced equation, now I have 1 mole of oxygen giving me 2 moles of water. Okay, and now if I do this calculation, my answer should come out to be 1.93 times 10 to the power of 6 moles of water. Okay, so now I look at both of the numbers and I see that 1.93 times 10 to the power 6 moles is less than 2.18 times 10 to the power of 6 moles, okay, of water. So which means that my limiting reagent is oxygen. Okay, because that is giving me the fewer moles of water, okay, or less moles of water produced. So my limiting reagent is oxygen. And then I have one final calculation to do. I will take my 1.93 times 10 to the power of 6 moles of water and convert that into grams of water. So this way I save one calculation, although it's not such a big deal. You can do it however you want. Both are fine. In one you just end up doing one more calculation. In this case you stop with moles and then compare the moles. So the answer is 3.49 times 10 to the power of 7 grams of water. Okay, and that is going to be our final answer. So both methods are correct. You can do it however you want. Okay, it doesn't matter. Both methods are fine. Whatever suits you.